Okay, so yesterday we learned how to simplify radicals, right? And the whole idea was that we used our perfect squares. That's the first thing we're looking for, right? So if I always write on my paper all my perfect squares. I don't use 1 because 1 doesn't change anything, right? So I'm going to start with my next perfect square, which is 4, 9, 16, 25, 36, 49, 64, 81, 100. And all I have to do to get these is I do 2 times 2. That's that. 3 times 3 is that. 4 times 4 is that. 5 times 5 is that, right? 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10. I know those are perfect squares. Again, perfect squares mean this. If this is a square, and this is 6, and this is 6, this is 36. And the square root of 36 is one of the sides, right? So it's a perfect square. It comes out evenly, right? It's a natural number. Yes?
But you could put 1, right? It could be 1, 4, 9.
You could. The only thing is, 1 doesn't simplify.
1 by 1 square.
Right? If I had the square, remember I did on the I think yesterday I did the square root of 12. If I said, well, that's the square root of 1 times the square root of 12.
Yes.
Oh, that's cool. That means that's 1 times the square root of 12, which is really just the same thing as the square root of 12. Oh, shoot. We didn't get anywhere, right? We just wasted our time. So I don't put 1 up there for that. But you are right. It is a perfect square. You're totally right. Right?
It would be a very small.
Yes. Now, if you guys recall, I asked you guys not to talk at all during my lecture today. Remember? So I just want you to honor that. That's really asking that for today. So I'm just reviewing right now. So if we had the square root of 75, I would ask myself, which of these things goes into 75?
25.
Well, it's going to be this. It's got to be one of these numbers in order to simplify, okay? Okay, so I do 25. I know the square root of 75 is the same as 25 times 3. So those are identical, which is the same thing as the square root of 25 times the square root of 3, which is then equal to 5 times the square root of 3, because the square root of 25 is 5. So everybody understands that now, right? Fist to 5. I just want to be sure. Everybody's getting that. All right? And I still don't want you to watch that lecture, okay? Because you missed it. But that's basically what we're doing.
This does seem familiar, though.
Yeah, you did not learn this with Matt, but it won't be hard for you to learn it, right? Yeah.
What I've been doing, I've been skipping like the first one where you do.
I skipped this one too. I'm just showing you, since it's clear that those are the same thing, right? This is sort of just one more stretch. That's why I've been writing that. But typically when I do it, I don't go to this root. I do this. Like if I said the square root of 24, immediately I'm thinking, 4 times 6, right? Right? So I go the square root of 4 times the square root of 6, which is equal to 2 times the square root of 6. I bypass this. I go straight to this when I do it, right? Because I know that the square root of 4 times 6 is the same as the square root of 4 times the square root of 6. I know that so well, so I just bypass that step. Okay? Now, what about this one? All right, let's simplify this one. Yeah, let's simplify this one. All right, so first thing, what do I do first of all? Yeah, so anything, or does it have to be something from this list? It has to be something from this list. Okay, so which of these goes into that?
None of them.
Who said none of them?
Wait, isn't 21 a prime?
It has to be something under 25.
What? Wait, what?
Is 21 a prime number?
No, it's not.
No.
No.
Prime, yeah, 7 times 3, right? No, it's not prime. No. So what is the problem, you guys? What is your problem?
What is our problem?
None of them?
Oh, wait. None of these go in? You're telling me none of these go into that?
18.
You could divide stuff.
All right. So listen, everybody's eyes on me for a second. You can't simplify this any further. Because none of these go into it. Yes, I could write it as the square root of 3 times the square root of 7. That doesn't help me.
None of those go
Because it has to be one of these so that I can take one of them out of a square root sign, right? Since I can't do that, that's as simple as it gets. You can't simplify it any further. So that's it. So you're right. That equals square root of 21. Easy, right? Okay. Now, right? So now that you understand the simplifying,
I do.
we're moving to the next level, okay? And the next level is understanding how to add or how to subtract radicals, okay? Do you have a question, Noah?
How? Okay.
I'm saying that you cannot simplify this because none of these numbers
So you
go.
can't simplify it at all.
No,
It's just
that's it.
okay.
The only other thing you could do is take a calculator
Yeah.
and type in square root 21
Okay. Yeah.
and put equals whatever that is.
I wonder what it is.
Right, but technically, if you did that with a calculator, the number would go on forever and ever, right? It would be, I don't know what it'd be. It'd be 4 point something, right? 4 point something, right? Goes on forever, right? And so really, this is actually more accurate than writing 4 point something because the something, it goes on forever, but I'm going to have to stop sometime. It's like I got to eat, right? So this is actually more accurate to write it as the square root of 21 than to write it as 4 point whatever, right? You see that? You understand that? Okay, so now we're going to talk about adding them, okay? So now that we've simplified, now we're going to say also adding, and adding, slash subtracting. Okay? So that's the second part. That's what we're going to really focus on today. So if I gave an expression like this, 2 times the square root of 10 plus 5 times the square root of 10.
So then would that be 7 to the square root of
10.
Well, that's an interesting question. I don't know. Would it be? So Adam asked this question. He said, would that be 7 times the square root of 10?
No, it's 20, I said.
Oh, 7. You said 7 times the square root of 20. Okay. So you said, could it be that? Okay. Weston.
Could it be 7 times the square root of 100?
Okay. That's an interesting thought. Both of these are interesting thoughts.
1.
It could be 1. Everything is 1.
No,
We are all 1.
No.
Oh, you are such a philosopher.
Yeah, thank you.
Okay.
No.
Okay, so yes, it could be 1. Right, okay, what else? All right, what if I did this? I'm going to write the same thing, only the same idea, but slightly different. Watch this. Ooh, what's the answer to the second one?
7x. So it's 7x. So it's
7x, right?
7
I have
to the
2.
10.
This says I have 2 x's.
That makes it so much more easy.
This says I have 2 x's, and then I'm adding to the 2 x's, I'm adding 5 x's. So how many x's do I have?
7
I have 7 x's. So Weston, what would you do with this now?
7, whatever that thing is.
Square root.
7 square root to the 10.
To 10, yeah.
Yes, the answer is 7 times the square root of 10.
Wait, how did you get the 10?
Because look, this says I have
Those
2
should have
square
stayed
root
the
of
same.
10s.
The square root 10 stays same because
This, you just have to remember what this number in front of the square root of 10 means. It means you have 2 square root of 10s. It means this. This means this. I'm going to get rid of this for a second. Let me erase this now so that we're dealing with it. So this means this. The square root of 10 plus the square root of 10. That's what this means. 2 square root of 10 means square root of 10 plus square root of 10. Right? I have 2 of them. That looks like 16. That's a 10. Okay? And then this says I have 5 of them. So I'm going to do the square root of 10 plus the square root of 10 plus the square root of 10 plus the square root of 10. 1, 2, 3, 4 plus the square root of 10. So how many square root of 10s do I have?
10.
I have 7 of them. So it equals 7 square root of 10. Right?
Ah.
Does that make sense?
Oh my.
So this is the rule. This is the rule. When the square root the number under the square root is exactly the same number, right? And you're adding, you can add the numbers, the coefficients. These are actually called coefficients, just like they were in front of the x's and y's. You can add or subtract the coefficients, right? And keep the thing under the square root sign exactly the way it is. So what's this then? So what if I had 4 square root of 13 minus 5 square root of 13? What would that be?
-1 times square root of 13. Yeah, wait.
-1 to the 13.
It would be -1 times
So
the square root of 13. Right,
Yeah.
exactly.
I have a
Good.
question.
All right, so we have 2 questions. One for Noah and then Okema.
So
Noah.
it's kind of like an exponent because it's like they're not like you can't do like 5 plus x. So it's like
Right, exactly. Yeah, you cannot do 5 plus x. It's like you can't do 4 plus 13, right? You can't do 13 plus 13. You got to do. You got to, as long as it's the square root of 13, square root of 13, then you can take 4 minus 5. I have 4 square root of 13s. I'm going to take 5 of them away, which means I have -1 square root of 13s, right? Yes?
What would you do if the number under the square root was different?
Ah, now that is a great question.
that's what I was going to ask.
Oh, Okema. Good question. You guys both are on the right track. Okay, so let's do this. What if I said this? The square root of 12 plus the square root of 27. Ooh,
Yeah,
dear.
that's what I was going to ask.
This is a problem. Doggone it. This is a problem. If the numbers in the square root sign are different, it doesn't mean you add them, right? You don't go, that's the square root of 39. It's not that. Never that. You never do that. Ever, ever, ever. Graham, what would you think?
2 times square root.
Oh my God, what is he thinking? Oh my God, could we simplify these individually and see what we got? Let's try it. All right, so Graham, so the square root of 12 is the square root of 4 times the square root of 3, right?
Yeah, so
Which is 2 times the square root of 3 plus,
3.
that's going to be square root of 9 times the square root of 3, which is 3 times the square root of 3. So I have 2 square root of 3s plus 3 square root of 3s.
So that would be 5 to the square root
And I
of
get
3.
5 square root of 3s. Look at that, that's the answer. They're really fun. I love doing these. Not everybody does, but I do. I like doing these. They're fun.
One sec.
Does that make sense?
Yes.
You guys get it? So when the
sense.
when you're adding square roots and the number under the square root signs are different, you have to attempt to simplify the square roots. Question.
Wait, but what if what if the other one, like 3 square root of 3, what if it wasn't square root of 3?
Okay, let's do one like that. I'll do it right here. Let's say we have this. The square root of 75 plus the square root of 8. All right. So the square root signs, what's underneath the square root sign are different, right? So we are going to do what we learned yesterday. We're going to simplify them first. So square root of 75, that's the square root of 25 times the square root of 3, right? Plus, this is the square root of 4 times 2, right? Square root of 4 times the square root of 2. So now I can simplify this to 5 square root of 3 plus 2 square root of 2. And my final answer is...
What?
God, you guys, my final answer is...
Not that.
that. That's my
Guessing
answer.
nothing, but
This is my answer. I can't do anything because look,
Oh.
this says I have 5 square root of 3s. This says I have 2 square root of 2s.
Oh,
I
makes
have
sense now.
I have 5 apples and 2 pumpkins,
That's
right?
segregation.
I can't say I have.
Segregation.
I can't say I have 7 papples, right?
But that means that.
Or umpkins. I can't do that, right? Right? So, does that make sense? If the number is not the same, you cannot add them.
If it's the same.
But you are expected to simplify them to this point so that we're sure you can't add them. Now there's one last thing I want to show you. Are you guys with me? Does this make sense? Just a 5. Just a 5. Okay, good. All right, so this one last thing I want to show you. What if I did this? What if I did this? 2 times, let me think about one.
3.
Okay, 2 times the square root of 24 plus, don't go yet. Where am I? What am I doing? 24, 2 squared is 6. 6 times 5, 25.
You can do it, Gary.
So 9 is 4. Okay, here we go. And 3 times the square root of 54. Okay. If I have these numbers in front of them. I've got to keep those. I've got to multiply that times my simplifying. So immediately I got to keep that 2. The square root of, what goes into 24? 4, right? So it's going to be 4 times the square root of 6. You with me? Yes? You get that? Plus 3 times the square root of, let's see, 9 goes into that, doesn't it? 9 times the square root of, where am I? 54. 9 times what is 54? Quick. 6. All right. So now, look, I have 2 times, square root of 4 is 2. That's 2 times. It's not 2 plus. It's 2 times 2 square root of 6 plus 3 times 3 square root of 6, which means I have 4 square root of 6. You with me?
Yes.
See what I'm doing? See what I'm doing? It's 2 times 2, 4, square root of 6s, plus 3 times 3 is 9
So you just have to multiply the
square root of
outsides by
6s.
themselves to get this.
Now I have 13 square root of 6s, right? There we go. That's a little harder. So the homework is going to involve doing these kind of things, as well as practicing last night's thing, simplifying. All right.